Okay, here we are. Today is day 21 on the Advent of Cyber Challenge. Today's challenge is malware analysis, Malhare.exe. And of course, we have two videos, video 1 and 2. And in today's challenge, we have two tasks. Task 1, introduction. Task 2, malware analysis. And of course, as always, before I begin, my disclaimer, I'm not a cybersecurity professional. I have no experience in or with cybersecurity. I'm a beginner taking on these challenges just like other beginners. And here we go. Today is day 21. So let's go ahead and start with the introduction. And download. Hold on here. So we will need an attack box today. And I don't see the attack box button. So sometimes at the top here. So we'll just go ahead and click Start Attack Box. Perfect. That's kicking off in the split screen view. And let's start with the introduction. So, and in our kingdom of Wareville, just like in others, thousands of files of all kinds pass through the systems every day, from docx, PDF, resumes received by our elves, to financial spreadsheets, CSVs, so comma separated values, from the accounting department, and executable files launched by different applications. But have you ever wondered which of these might be malicious? Which ones could actually belong to King Malhare? An interesting question, isn't it? So learning objectives for today. In this task, the TBFC SOC, so Security Operations Center, will investigate one specific file type, the HTA format, which is HTML application files. Okay. This is a file or a type often used for legitimate purposes, yet just as frequently exploited by attackers. Your mission is to reverse engineer the HTA and uncover how King Malhare tricked Wareville's elves to do this. You will need to look for, so we're going to go ahead and click out of this here. We will need to look for application metadata, script functions, and any network calls or encoded data, clues about exfiltration. So, of course, we need to review the questions and connection card. The only thing we're going to need today is the attack box, which we've launched here. And we can see that it's starting to load for us. So once we click on the Start Attack Box at the top of the page, we're going to open the malware sample using pluma /root/rooms/AOC25 day 21 survey.hta. Close out of this. So important, this room uses HTA malware file. It's safe, but do not run it locally. For safety and the intended experience, you should use the attack box. The file is already provided there. If we download it manually, browsers may block it. If it does download, open it in only a text editor. Do not execute it. So of course, the only question for task 1 is my attack box started, and I'm ready to start learning about malware analysis. So we're going to go ahead and check that off. We'll pause here, and then we'll come back and start task 2. Okay, here we go. We are in task 2, malware analysis. And maybe for the ease, I don't know if I want to open this in full screen just yet. We might wait. So not long ago, in the summer of 2025, researchers discovered that ransomware groups were using HTA files disguised as fake verification pages to spread the Epsilon Red ransomware. During this campaign, many organizations were affected, and security teams were reminded how important it is to understand HTA files and what HTA files are, and why they appear so often in corporate environments. So what exactly are HTA files, and why do they exist? In Wareville's digital kingdom, not every strange-looking file is a threat. Some were originally created to make the daily work of developers and administrators easier. One such helpful invention is the HTA file, short for HTML application. An HTA file is like a small desktop app built using familiar web technologies such as HTML, CSS, and of course JavaScript. Unlike regular web pages that open inside a browser, HTA files run directly on Windows through a built-in component called Microsoft HTML Application Host, or mshta.exe, and that's the process here. This allows them to look and behave like lightweight programs with their own interfaces and actions. In legitimate use cases, HTA files serve several practical purposes in Wareville and beyond. automating administrative or setup tasks, providing quick interfaces for internal scripts, testing small prototypes without building full software, and offering lightweight IT support utilities for daily use. So in short, HTA files were designed as a convenient way to blend the simplicity of the web with the power of the desktop applications, a tool that many TBFC's engineers and elves still use to keep SOCMIS operations running smoothly. So we have HTA file structure. Before the defenders of TBFC can recognize suspicious HTA files, it's important to understand how a normal HTA file is built. Luckily, the structure is quite simple. In fact, it is very similar to regular HTML page. An HTA file usually contains three main parts. The HTA declaration. So this defines the file as an HTML application and can include basic properties like title, window, size, and behavior. The interface, such as HTML and CSS. This section creates the layout and visuals such as buttons, forms, or text. Then we have the script or VB script or JavaScript. Here is where the logic lives. It defines what actions the HTA will perform when opened or when a user interacts with it. Here's a sample example of the legitimate HTA file and what it might look like. So we have the HTML tag, the head tag, then we have our title, which is TBFC utility tool, the HTA application, we see our ID, application, border, caption, and show in taskbar. The closed tag for the head section. Then we have the body tag with an H3 tag here. Welcome to the TBFC utility tool. Our input, which is going to be a type of button, value that says hello on click. So that's going to be a piece of like the script. So this small example creates a simple desktop window with the button that shows a message when clicked. In real cases, HTA scripts can be much longer and perform important tasks. It's easy to see why developers liked HTA. You can build a quick functional tool using nothing more than web code. However, as TBFC's defenders will soon learn, the same flexibility that makes HTA convenient also makes it powerful enough to require careful attention. So before we begin, we're going to come back here to how King Malhare turns HTAs into weapons. But I want to review how many questions we have here. So we have, what is the title of HTA application? What VB script function is acting as if it is downloading the survey questions? What URL domain, including subdomain, is the questions being downloaded from? Malhare seems to be using typo squatting, domains that look the same as real ones, in an attempt to hide the fact that the domain is not the intended one. What character in the domain gives this away? Malicious HTAs often include real-looking data like survey questions to make the file seem authentic. How many questions does the survey have? And notice how even in code, social engineering persists. Fake incentives like contests or trips hide in plain sight to build trust. The survey entices participation by promising a chance to win a trip to where? Holy moly. It's like 11 questions here. The HTA is enumerating information from the local host executing application. What two pieces of information about the computer is it running on or being on? What is it running on are being exfiltrated? I feel like that's what two pieces of information about the computer it is running on are being exfiltrated. Okay. You should provide the two object names separated by commas. What endpoint is the enumerated data being exfiltrated to? What HTTP method is being used to exfiltrate the data? After reviewing the function intended to get the survey questions, it seems that the data from the download of the question is actually being executed. What is the line of code that executes the content of the download? Holy moly, man. It seems as if the malware site has been taken down, so we cannot download the contents that the malware was executing. Fortunately, one of the elves created a copy when the site was still active. Download the contents from here. And what popular encoding scheme was used in an attempt to obfuscate the download? Decode the payload. It seems as if additional steps were taken to hide the malware. What common encryption scheme was used in the script? And either run the script or decrypt the flag using online tools such as CyberSecurity. What is the flag? holy moly, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 questions. Well, let's hope that they do a decent and thorough job at explaining how to get through this, but I have a feeling I'm going to knock on wood first and hope that they do a very amazing job at breaking this down for us. But through my experience, I'll just stop there. Anyway, HTA files are attractive because they combine familiar web markup with script execution on Windows in the hands of a defender. They're a handy automation tool in the hands of someone wanting to bypass controls. They can be used as a delivery mechanism or launcher. Common purposes of a malicious HTA use initial access delivery. HTA files are often delivered by phishing, email attachments, fake web pages, or downloads, and run via Malhare.exe, downloaders or droppers. An HTA can execute a script that fetches additional binaries or scripts from the attacker's C2. Obfuscation and evasion. HTAs can hide intent by embedding encoded data, base64, by using short VB script or JavaScript fragments, or by launching processes with hidden windows. And living off the land, HTA commonly calls built-in Windows tools such as mshta.exe, PowerShell, wscript.exe, and the Rundle132.exe, or is that Rund11? It looks like Rundle, like LL. 32.exe to avoid adding new binaries to the disk. Inside an HTA file, you'll often find a small script that may be obfuscated or encoded. In practice, this tiny script usually does one of two things: downloads and runs a second stage payload, or opens a remote control channel to let something else talk back to the attacker's server. These lightweight scripts are the reason HTAs are effective launchers. A single small file can pull in the rest of the malware. Here's a sample of King Malhare's. Here's an example that King Malhare might try to use. So we see Angry King Malhare, HTA application. We see the ID. And then VB script, option explicit. Okay, so the PowerShell, I'm assuming this is where the payload is. I don't know. Self.close. As you can see, the HTA is very different from the simple example that we provided earlier. It contains a number of obscure elements that observe a closer look. Let's walk through it. When analyzing HTAs, the title and HTA application tags often reveal how attackers disguise malicious apps. They might use a convincing name like salary survey or internal tool to appear safe. Always check these first. Secondly, there's a VB script block marked by script, language equal VB script. That's the active part of the file where attackers often embed encoded commands or call external resources. Inside this block, we find a PowerShell command, b:" equal PowerShell dash no profile dash execution policy bypass dash command, a pattern commonly seen in malicious HTAs used for delivery or launching. The PowerShell invocation contains a base64 encoded blob from base64 string. This is likely a pointer to further instructions or a downloadable payload. If you see an encoded string, assume it hides a URL. Decoding it reveals the attacker's command and control or C2 address and or a resource used in the attack. Always decode before assuming what it does. So malware authors often use multiple layers of encoding and encryption, such as base64 for obfuscation, as some of the encryption or cipher as a form of encryption or cipher to conceal the true payload. When you decode the base64, check whether the output still looks like gibberish. If so, a second decryption step is needed. For analysis, we'll extract what base64 code and inspect it with a tool like CyberChef to reveal what it hides. So for analysis, we'll extract the base64 code. So I'm just going to copy this. That way I can grab that entire string, open my notes here. And then let's get rid of this. And let's get rid of this. Let's minimize. Let's open CyberChef. Let's copy this. And then from base 64. So we can see https raw.kingmalhare.com c2 silver refs heads main redacted.txt. Okay. Note in the example, we've redacted the remote resource and replaced the real link with the redacted.txt file for safety. In a real incident, that string would usually point directly to a file hosted on the attacker's C2 domain, for example, a URL under kingmalhare.com in our SOCMS story. After the encoded PowerShell command, we can see three key variables, which is the variable of U, variable of C, and variable of B. Okay, were we supposed to open something here? Because it did not tell us to open anything. Let me check task 1. So let's go to root, rooms, AOC 25, day 21, open with, let's do Sublime Text, text editor. Cancel. So let's minimize this, close this. Okay. Come back to task 2. Let's scroll back down. So right here we see the variable of U holds the decoded URL and the location. What is it talking about? Redacted text. So desktop, tools. We don't have any documents on this thing? Guess not. After the encoded PowerShell command, we can see three key variables. Maybe it's just talking about this. Yes, okay. Variable U, C, U, and B. Okay. So U holds the decoded URL and the location from which the next script or payload will be fetched. Variable of C stores the content downloaded from the URL, usually a PowerShell script or text instructions, and variable B converts that content into an executable script block and runs it directly in memory. Yeah, I have a feeling this isn't gonna be so helpful on the breakdown here. Whenever you see a chain of variables like this, try to trace where each one is created, used, and passed. If a variable ends up inside a function like run, execute, or eval, that's a sign that downloaded data is being executed, a key indicator of malicious activity. As a summary, the process of reviewing suspicious HTA can be broken down into 3 main steps. 1, identify the script's section, which is a VB script. Step 2, look for encoded data or external connections, such as base64 or HTTP requests. Follow the logic to see what's executed or being sent out. I think we forgot the D here. And we reviewed how attackers might use an HTA file for malicious purposes. Now that you've seen how HTAs can combine HTML, VB script, and PowerShell, you'll apply the same process to analyze a suspicious one. Start by locating scripts section, then identify functions, encoded strings, and any references to URLs or system calls. Decode anything that looks like it is hiding information, then trace how the script uses the results. Now it's your turn to work out what the evil king's minions did. From surveys to security failings, our team figured out that one of the elves' laptops were compromised. Working through the incident, it seems that the one common denominator between them all is a survey that they completed regarding their salaries. The investigation found that an email was sent to these elves with an HTA attachment. The team is asking you to review the HTA file and provide feedback on what it is actually doing. You can choose to either use the attack box and find the file at root rooms AOC day 21, which we did, or download the attached task file and perform your own analysis. So use a text editor to view the HTA to ensure that it doesn't execute, and you can use Pluma on the attack box by running the following command. Oh, so we can, what is Pluma? Oh, Pluma text editor. Okay. Well, I just opened up in Sublime. Oh well. So we did open it. Let's go back here. And so same thing here. We see the opening and we see the script section here. So it's a JavaScript. Function visited, function never, function submitted, function submit. And then we have some script of a VB script. Same thing, we got a function section, the in function, function section, in function, so on and so forth. And then for style, we have the style section here. And then we have our body. Anonymous salary feedback. And we have an image right here. It's base 64 right here. So a GIF that's base 64 encoded. Thank you for the feedback. All participants be entered. We see the idea of submit button, submit, close. Okay. So next we want to understand what the HTA actually does. This means we need to search for the VB script section, which we did. Scroll back up here. That's the style section. That's the VB script section. So window_on_load, this function will automatically execute the HTA loads and executes the get questions function. So on load, call get questions. So we see this right here, function. So result decoded string, Internet Explorer.application, i.e. navigate to http survey bestfestivalcompany.com/surveyquestions.txt, do while IE ready state. Oh, lovely. Not entirely sure what happened here. Let's see. Let's go full screen. See if that helps. Cool. And let's exit this one here. So get questions function makes some external requests, then ultimately runs the decoded base 64 function and calls provide feedback function with the data, provide feedback, the feedback string. This function gathers some data about the computer, makes some external requests, and then ultimately executes something we will still need to analyze. Decode base 64. This function takes in a base 64 string and converts it into binary. RS binary to string, X binary. This function takes the binary input and converts it back into a string. Within these functions, we want to understand the real actions being performed. They are usually denoted by create object, with our application containing a couple such as Internet Explorer application. We did see that allows the application to make an external connection. wscript.network connects the computer's wscript networking elements to uncover information. wscript.shell creates a wscript shell that can be used to execute commands on the computer. And lastly, we want to understand the HTA actually looks like to the user. Here is a very similar to HTML files. To do this, we need to take a look at the body section part of the HTA. Starting at line 169, this is the part that will actually be shown to the user using the information and steps given above. It is time to perform an analysis of HTA and figure out what King Malhare is up to. So what is the title of the HTA application? So let's go back up. Title is Best Festival Company Developer Survey. Copy. Paste that bad boy there. What VB script function is acting as if it is downloading the survey questions? So let's go down to, I would say, window on load, because then it's calling the questions. So let's do this. Okay, that's not it. So maybe it's get questions. Copy that. Nice. What URL domain, including subdomain, is the questions being downloaded from? Well, create object, Internet Explorer application. It calls out to http://survey.txt. Let's copy this. Well, that's not it. Maybe it's this section. Let's just copy this. It still looks too long. Let's grab that. Nice. Malhare seems to be using typo squatting domains that look the same as a real one in an attempt to hide the fact that the domain is not the intended one. What character in the domain gives that away? It's an I, because we see instead of best festival, it's two I's right here. Malicious HTAs often include real-looking data like survey questions to make the file seem authentic. How many questions does the survey have? Well, I think we need to go down to the body. And we can see here's a header 2. So we see header 3. There's 1, 2, 3, 4. I'm going to go with 4. Notice how even in code, social engineering persists. Fake incentives like contests or trips hide in plain sight to build trust. The survey entices participation by promising a chance to win a trip to where? So we are looking for your feedback to help us improve the employee relations. This survey is completely anonymous. Lies. Don't ever believe that. Insert survey. Background. Thank you for your feedback. All participants will be entered to win a prize for a chance to win a trip to the South Pole. So, South Pole. The HTA is enumerating information from the local host executing the application. What two pieces of information about the computer is running? What two pieces of information about the computer it is running on are being exfiltrated? You should provide the two object names separated by commas. HT is enumerating information from the local host. Well, let's go back up. Check the VB script again here. So we see get questions, provide feedback. So str host, str user, str domain, on air, resume next. I'm going to say these two. Let's see. Decode base 64. if L binary, then RS fields. Might have to take a hint. What? The HTA is enumerating information from the local host executing the application. What two pieces of information about the computer it is running on? About the computer it's running on. Is it computer name and username? We'll do computer name, comma, username. Yes. What endpoint is the enumerated data being exfiltrated to? What endpoint is the enumerated data being exfiltrated to? What endpoint? So on error, resume next. Dim IE, create object, navigate to IE.quit, decode base 64. That one I don't know. I see PowerShell. It's not PowerShell. It's definitely too short for PowerShell, so let's get a hint. Trace where the enumeration data is sent. Look for HTTP commands referencing a path. Got it. I saw that up here. So we'll say HTTP survey best festival is it /details. Copy this. Paste that. Check. Okay. What HTTP method is being used to exfiltrate the data? What HTTP method is being used? Loop set. Is this set? Call. There's no way it's that. Yeah, I didn't think so. Maybe a get? User, IE quit, run object, hidden, feedback string, false, in function, decode. Yep, I'll have to grab a hint. Review the exfiltration line. Is it adding data as URL parameters or in the body of the request? Review the exfiltration line. Is it adding the data as URL parameters or in the body of the request? Provide feedback string. Do while loop, IE quit, run object, set run object equals create object, wscript shell, then run PowerShell.exe, hidden, decode, base 64. That one I don't know. calling out to a URL, so is that what it is? Get request. Okay. I don't know where that's located at, but after reviewing the function intended to get the survey questions, it seems that the data from the download of the question is actually being executed. What is the line of code that executes the contents of the download? After reviewing the function intended to get the survey questions, it seems that the data from the download of the questions is actually being executed. What is the line of code that executes the contents of the download? Would it be this full string here? We'll copy this. No. After reviewing the function intended to get survey questions, it seems that the data from the download let's try this one. I don't think it's this either. There's no way. So let's go grab us a hint. Follow how the downloaded content is stored and used. Identify the specific line where the script takes that content and executes using run, execute, or script block. Get questions, okay. Follow how the downloaded content is stored and used. Identify the specific line where the script takes that content and executes it using run, execute, or script block. Provide the full line. If set right here, run object.run. Copy this. Hopefully this is it. Paste that. Nice. It seems as if the malware site has been taken down, so we cannot download the contents. Fortunately, one of the elves created a copy of the site, was still active. Download the contents from here. What popular encoding scheme was used in an attempt to obfuscate the download? I thought it was base 64. I thought we saw that inside the script there. Yeah, I was about to say, I could have swore we saw that. Right here, decode base 64. So decode the payload. It seems as if the additional steps were taken to hide the malware. What common encryption scheme was used in the script? Decode the payload. It seems as if additional steps were taken to hide the malware. What common encryption scheme is used in the script? So after decoding it, if the result still appears scrambled, look through the script encryption. Let's grab this. Let's go here. So what if we do from nope, that wasn't it. Run magic, grab that. Valid UTF-8 entropy. Decode the payload. It seems as if the additional steps were taken to hide the malware. What common encryption scheme was used in the script? Okay, so let's go back here. Let's take that off for a minute. We see the function, new objects, if decode the payload. It seems as if additional steps were taken to hide the malware. What common encryption scheme is used in the script? And then CyberChef can help here if you just give the scrambled flag line. Well, let's turn this one back on. Function AABB. Valid UTF-8. I don't know. So from base 64, and then from base 85. Well, that's not it. So let's go back. Let's turn this back on. And I do see new object, else if this one here. So copy that, or should I copy all this? Let's do paste. Close this one. We'll turn this one back on. This is base 85. Let's do base 85. Well, it's not base 85. At least I'm not doing it correctly anyway. Matching ops from base 85 valid UTF-8. So let's close this here. Let's grab this one more time. Paste that. Turn that back on. So whatever this is. We'll do magic again. this one's stopping me. Decode the payload. It seems as if additional steps were taken to hide the malware. What common encryption scheme was used in the script? Let's come back. So we see base 64. Would it be binary? Nope. Create object A. Function decode base 64. Okay, well, let's go back up. And then so decode base 64. XML DOM. No, it's going to be 5 characters. Dim binary. If var type x binary equal 8, then binary equals multi-byte to binary x binary, else binary equals x binary. Character 201, len b binary, then fields dot append in binary, l binary, rs dot open, rs dot update. I don't know. Data image / GIF base 64. Well, I may have to pause and then come back on this one because I'm not 100% certain. So I'm going to take a pause here and then I will come back. Okay, we're back after watching through a short video here. I was able to figure it out through them actually coming right out and explaining what we were looking for. But again, not a cybersecurity guy, so I would have never got that. So if we come back into CyberChef, I was explaining that these sections here are the exact formulas for ROT13 or ROT13. So we're going to go ahead and remove this. We'll add ROT13. Add that here. And now we can see the flag, which is here. So if we turn that off, we'll see it flips back and turn it back on. There we go. So we'll come back to our questions and we'll do ROT13, which just rotates the characters 13 letters ahead. So A would jump 13 letters, B would jump 13, so on and so forth. We'll hit check. And we can also go back, grab our flag, go ahead and grab the T, Control C, come back here, paste it, check. Awesome. And for those who want another challenge, we can download the HTA file here. We can do side quest 4. I'm good. And if we enjoyed this room, we can also do other rooms called Maldoc, static analysis, but I'm good. We'll check that. Hit continue. Still only 1 ticket. I wonder if anybody ever gets more than 1 ticket. Okay, so that's going to be it for this one. We're going to go ahead and terminate this machine. We'll close out of this, close out of this, close out of this. And no target machine today, right? That's right, nothing here. Okay. And I won't lie, the video that I ended up using for help was going to be this first video here. So that was very helpful for them to notate and explain these sections here for us. And that's going to be it for today's challenge.